Hello. Um, I think this is the first class for the Python coding in Python language. So we have to start with the values, variables, and built-in functions. So there are two players in the computer programmings. So you can play as a developer or you can play as a user. As a developer, uh, you need to use a command line user interface, which I'm going to show to you. This is a command line, right? Like this. This is a terminal. So right now I am in user slash jun. As a user, you can do both graphical user interface in most cases, or also you can do a command line user interface. This class is to teach you, or you may be able to learn uh, the programming language in developer's point of view and also a user point of view. As a developer, of course, in many cases, we develop a small program. And also, as a user, you need to sometimes use some of the programs already developed by someone else. Well, actually, there are tons of big the software packages already available, so we simply use it. Um, I got a call, so I need to. Sorry, yeah. Sorry for that because I got a call. All right. So tons of software packages are already developed by someone else. So as a user, we simply use it and improve a little bit uh, by putting a few more blocks on top of the blocks already built. Okay, so I would say this is building blocks. So I can put one more blocks on top of uh, the blocks already built. In order to do that, um, I would say our coding is not only as a developer's point of view and also the user point of view. Mainly because we do not develop anything from scratch. Sometimes we could do that. In most cases, we're going to build on top of the blocks already built. In that case, the building, the blocks that we want to use as a basis of our coding, then that will be we simply putting it into our program as a user. So we need to know how we can import some of the packages, modules that already developed as a user. So we bring it as a user. So we need to understand how it is built. Therefore, we need to make an invocation of that the blocks. Plus, as a developer, we need to make a more of the small blocks to place in or on top of the blocks already developed. Okay. First, user interface is a command line, so we can see some of this. This is the terminal that you can see. I'm going to this. Say Python 3, then it runs. In my case, Python 3.12.2, 3.14.2. I think that is this is a current version. So I can make some the computation 4 plus 5, then that is 9, right? And 2 times 11, then that is a 22. That type of computation is possible. So arithmetic operation is possible. Some of the arithmetic, that's binaries, so that we can have, for example, this kind of things. Percent sign, that gives us, for example, 11 percent. What is a percent? Percent to 2, then it returns 1. 11 times divide by 2, then it returns 5.5. So what I mean by slash? Forward slash means that is simply a divider. 11 divided by 2, then there's 5.5. It returns the quotient, the result of that division operations, right? On the other hand, this 11 percent 2 returns 1, we call, is called modular. It returns the remnant of a division. So for example, 11% to 2, then it can be divided by 5, right? It can be divided by 5. And remnant, this is it's a completely divide. So this is 5.5 itself is a quotient. But we can do 11 equals 5 times 2. If we say this, look here, the equal sign means equal a verifier for equality. So 11 is 11 5 times 2. Of course, it is not, right? So it has some issue, right? But I think if we do, let's say, print if 11 equals 5 times 2, I'll do this later. Okay, so this 11 is not 5.2, right? We know that 11 is 5 times 2 and plus 1, right? So 1 is the remnant. 5 is a quotient in integer, right? But the result of this division itself is the 5.5. But we can make 11 is nothing but 5 times 2 plus 1, and therefore 11 is the remnant. So when you do this 11% to 2, then it returns 1. Okay, and we call that it is a modulo. So modulo and divider. Okay. Variable. What is a variable? Variable is a placeholder. Like when you see the drawer, there is a label, name. So if we pull this drawer, then inside we can see the value that's associated with that label. So actually, if you see this drawer, the label is name. In order to get the value, then you need to do, if you want to print it, then you can use, print is a function that already defined, whereas already built. This is a so-called built-in function. You don't need to implement the print function because it is already built. So what we need to do, also as a the developer programmer, many times we simply use it as a user. It is like a building blocks. So we want to bring the blocks built by someone else. That means how we can use, right? And on top of it, we want to implement some of the small block put on it. That is a development. So we can say name equals John. Then what actually was when you do John, then that is John, right? If you see this is a value, right? This is a value, 11 divided by 2. 11% 2, that is also a value. So the reason that we need to code is to manipulate the values. Actually, we want to manipulate the values. But in order to manipulate the values, in other words, in order to, once we have that value, but if we want to reuse it, anyway, if we want to use that value, then we have some label that can hold that value, right? If we want to use this John, so we know how we can make John, like here, right? So it returns John. We know John, but if we want to use this John, then we need to have some of the label. This label points to that value. How can I do that? I know John, but if I want to use it, then I need to do name equals John. So the right-hand side, this is my value. Left-hand side, that is a label. Some other times we call this a variable. Some other times we call that placeholder. So labels, placeholder, variables. More formally, we call it labels. But you may think of it as a labels and placeholder. Because it is a placeholder, if you know what is name, then it returns name. Name, I can use it multiple times, right? I can do, for example, use that on as a parameter. So that print. What is a print? Print is a function. Well, let me get some of the print. So help. And if you do print, then it returns what is a print. There is a built-in function. So print takes arguments. So we will see that what we mean by the star arguments. It means arbitrary number of arguments. Okay, so print can have multiple parameters. Print, and this print returns, okay, what it returns. Okay, I think this is it, yeah. And then we need to quit. And then now name is, as we labeled, as we declare the variable name that can hold the value John, so still that have it. How long that is available? As far as the Python is up and running, which means as far as we have here, this prompt statements. So without having that, we have the prompt statements like this. This is the regular prompt statements, right? This is prompt statements. Everything that is prompt statements. But when I call Python 3 in my case, then I have new prompt, triple greater than sign. So I can use print, for example, my name is John. Then if I have print takes 0 or more arguments, in this case 1 arguments, because everything in the double quote, everything is as a string, like as I do here, John, that is as a string, right? If it is under, I mean everything here, when I say my name is John, as a string, then I need to put here double quotes. In that case, it can understand, hey, that is a string, so I do not need to evaluate it. I just take it. As I take it as is, and then this function says print it. Then it returns print. My name is John, right? When I simply say my name is John, then it'll return errors because it tries to evaluate all of this, right? So it is an error. But if I do quote, my name is John, quote and unquote, and hit enter, then it doesn't do. See the difference here? When I type this, hey, file, there's an invalid syntax, right? When I have a quote and unquote, then it says, it take it as is, right? So when I do print, my name is John, then it takes it as is, and then what? And then function here says print, so it can print it. All right. Another function, for example, input. And then if I say my name is John, then the exact same one in string, because quote and unquote, like here, if I put that string into this different function input, here in this case a print, therefore it prints, right? Input, then that is an input prompt. So it says, my name is John, right? What that means is that is simply like in many cases, input, and then we can say, enter your name, like a prompt. Then it, because if I do double quote here, then ending with the double quote. If I make a double quote as a beginning and ending with the single quote, then we have an error. Okay, so double quote and double quote, then it says enter your name. Then I can do John, right? Now, back to print. Print my name is John. As we know that this is everything here is a string. Because it is a string, do not evaluate it. And then what? because this function says print, so it is being printed. I know still when I say name, when I do name in this case that is evaluated. So rather than see the difference, when I do name quote and unquote, then it returns name as is, right? But if I do not have quote and unquote, simply whatever that is, right? This is a variable. Then it is evaluated and it says what that variable contains. So it returns John. When I do this quote and unquote, then this Python doesn't care. Just take it as is and then wait, right? So name holds John. The variable, in this case, a variable name. It holds value John. In this case, this itself is a value because of quote and unquote. This name and that name are not the same. This is a variable. This is a value. So back to print statements. If I say my name is, and then I can say something, but I want to make it like this. But this John, not as a hard-coded John, this is called hard-coded. John is coded hard, right? It's not soft-coded. But how can I use the variable? Because the variable has John. I want to use this variable. Then I can simply put here name. Okay? So back to the function print. Print function can take 0 or more arguments. This is the first argument, everything in quote and unquote, comma. Second argument is name. If you see first argument and second arguments, the difference is the first argument is a string because it is a quote and unquote. Second argument here, there is no quote, which means it should be evaluated. But we know if it is evaluated, then it holds John. So probably as this is evaluated, we will have a John. So see what happens, right? So two arguments are put into this function print. Then it returns here, my name is John. Oh, very similar, right? Like this. Similar means not exactly because this is a one space, but this is a double space. In order to avoid that, then if I push this back, so I do not have any extra space there, simply John, and immediately close the double quote, then it returns like this. My name is John. In this case, this is exactly the same as this, right? So we can make print and then my name is John as a string, or we can make print my name is, that is a string, comma, variable name, whatever this name contains. In this case, name contains John. So when this variable name is evaluated, then that variable returns John, because this variable is nothing but a placeholder of this value, John. I think you understand, fully understand. Okay. So pictorially, when I say name equal John, these statements, then in memory, in your computer memory, there is a John value placed somewhere in the memory, and then there is the label. This label holds that value. This is what's going on on your computer, particularly on your memory. your RAM. So what happens if you would have your area equals the length times width? If we simulate that similarly, then we can define, for example, length equals, let's say, 7, and width equals 3, and then I can compute area equals length times width. So length is a placeholder. It holds value 7. Width is a placeholder that hold the value 3. Next statements here, one label area equals what actually here, as I explained here. In other words, this means value 7 is assigned to the variable length. Value 3 is assigned to left-hand side width. Similarly here, on the equal sign on your right-hand side, whatever the value here that assigned to the left-hand side, whatever the value here, right-hand side. So right-hand side is assigned to value length. Right-hand side, the value 3 is assigned to the variable width. Now here, whatever the value of this computation, here multiplication, right? I want to multiply. So length times width, is it possible? For example, if I do height times weight. Right here, I didn't have any issue, right? It returns very nicely. There is no error messages. But when I do this, then I would have error messages. Why? When I do this, it tries to evaluate. Evaluation means what is the value of this times what is the value of this. So I need to have a value, those two values which are contained in this label. But this height and weight, not defined at all here. This is not defined. But when I do here width and length and width, I already defined. When this guy is the right-hand side, when this right-hand side is to be evaluated, length, oh, I got the number because length is labeled. I know what value is contained in it. Width, the same thing. Therefore, I can evaluate this. The result of this multiplication is 7 times 3, then there's a 21, right? That is assigned to the left-hand side, the area. See, what is the area? Oh, that's a 21. I know already, right? There's a 21. That is exactly the here, length and width and area. So we have 3 values in memory, and those 3 values also pointed by the label. Okay, pointed by the label. This is pointed by that, and this is pointed by that, and this is pointed by that. So if we want to print that, then you can do print area, then we know that's 21. And also we can do more nicely. For example, length, and then I can say multiplied by width and equal sign, then it'll be area. Some of you may figure that out, right? What does this mean? This print statement has how many arguments? 1, 2, 3, 4, 5 arguments. First one is length. Because there is no quote, so it should be evaluated. By the way, length is already defined, which is a placeholder holding value 7. So this will be 7. And then next one is the star asterisk. This asterisk is in quote and unquote, right? Which means that is a string. So it is not to be evaluated. it is written as is. It is written as is, right? Like here, it is written as is, right? Because they are in quote and unquote. So this asterisk star written as is. And then the third parameter here, width, that is already defined also, which is nothing but 3. And another string, equal sign, it written as is. And then the last one is area. We know the area holds the value 21. And this print statement takes, this print statement takes 1 parameter, right? This print statement takes 5, right? It could be possible. So when I hit return, it shows like this. 7 times 3 equals 21. Very nice, right? Okay, then we will go further. Data types. Why data types? As I first introduce to you guys, whatever data that you want to compute in computer, then data should be loaded. As data is loaded, because you want to compute, you have a label to hold that data. So that label is, in other words, in a proper terminology, that is called a variable. So variable holds a value. Now we have the issue. If we have similar values, like 100 such, or millions, should we declare each one different variables? For example, name Sam Smith. If there are hundreds of students' names, then should I say name 1, name 2, name 3, name 4, name 100? Would there be any other way that we can declare it efficiently, as well as retrieve it in easier way? So we need somehow data types like this. We have so many on this slide, maybe 10 values. So we want to play with those 10 values. Therefore, load those 10 values. For each value, then I need to have some labels, variables. So I may need to declare that many variables. So that is not efficient. All the programming language, I would say all. If it is not, then we don't call it programming language. As primitive data types. For example, list. Those who learned similar things in another language, you may recall array. So array may be a list. So you can hold a sequence of a series of values. Pictorially, I put there a list. So we have a number of names in one variable, and they can be in one container, bracket. So that is a list. Similarly, we have a tuple. Tuple also holds a series of data. As you can see there, John, 1, cyber, IoT. In representation in Python, those series of values can be composed by parentheses. But many other languages not necessarily differentiate that, but Python does. Uh, for example, Java, then list and tuple, those are all array. Similarly, in Swift, which is the language that you may, if you want to take what about the course that I am teaching, iPhone apps development course, which is called Mobile Technologies and Sensor Data Services, then the language that we are using is called Swift. Swift is not like Python in a way differentiating a list from tuples, all like array. But dictionary is different. So we have also a dictionary. Dictionary is a mechanism provided by Python, also possible in Swift. Java, the earlier version of Java does not have dictionary type. I've taught Java till I think 10 years ago for 15 years at that time. And also I wrote 2 books in Java, probably not available now. I'm the first generation of Java users. I started my Java programming in 1995, which is the same year that Java was first announced publicly by Sun Microsystems. Currently, it is managed by Oracle, but it was invented at Sun Microsystems. MySQL also invented by Sun Microsystems. Sun Microsystems is a really, really good company. I am still missing that company. In 1990s, I think Sun Microsystems is the best company. Like this time, maybe OpenAI or Tesla, Apple, Google, something like that. Technically, the company leads the world. I would say OpenAI or Tesla. So what is a dictionary? Dictionary is one of the data types that holds a series of data like list and tuple. But one significant difference from the other two is the way it is organized, the way it is accessed. As you can see here, if it is a list and tuple, then I put here a number, right? We call that index 0, 1, 2, 3. So we know, so the position is very, very important. John, Adam, Brown, Peter, David. If David comes next, then he is always the 5th position in that list. Yeah, unless we explicitly swap this with others. But anyway, it should be there, right? There's an index. Based on index, position is important. On the other hand, the dictionary. I wanted to recall real dictionary. Probably many of you still you are very young, 20s, 30s. So when you learn the languages, I mean real spoken languages, you probably didn't use a printed dictionary booklet. Then what is the dictionary? Dictionary is to give you any explanations or annotations if you give me a word, right? Mercy, for example. Hey, what is mercy? Then that dictionary gives you the annotations, explanations, or detailed definition about mercy. That is a dictionary. So dictionary is a container holds key and value pairs. Key is like lang here, value is Python. Key is major, value is cyber. For example, what is your job? Job is a key. the value associated with this key is cyber engineer. Cyber engineer. What is a research? The key is RES. The value to this key is IoT, Internet of Things. By the way, what is a cyber engineer? Cyber engineering, cyber engineer. One of the cyber security professionals, right? Cyber security science, cyber engineering. What is the highest prestigious job title in cyber security area? That is a cyber engineering. Cyber engineering requires, I know some of you are from engineering background and also great skill sets of science. And as you complete your cybersecurity master's program, then you can pronounce yourself cybersecurity engineer. You can do not only not only science, but also engineering. Not only coding, but also manipulating devices. So coding is not simply running on your computer itself. So your programming language needs to identify what's going on in outside, like sensoring. And also, your code should do some of the actuations. It should take some action correspondingly to the situation changes. So you should know not only soft things and also hard things. And cyber engineer should do not only cybersecurity operations, but also cybersecurity developments. Probably I said that right. OpDev, operation and development. Right now, there is another thing, one more, OpSecDev, operations, cybersecurity, security, and developments. So for example, as you develop, then you have to carefully consider to protect whatever the target that you want to deploy, right? Not careless developments, but your deployable deliverables should be securely running. That is OpSecDev positions. But anyway, so this is a dictionary. So we have a list, topic, and dictionary. So we'll look at how we can use that. This is another the real motivations. For name 1 equals John, name 2, we should declare 10 of those. And when we access, then we need to, one of the primitive access of name 1 is by printing it, right? I want to print name 1, print name 2, print name 3. We need to do that. But if we do, for example, this is a container called list, and I want to call it language. So language is a variable, only one variable. This variable can hold multiple or series of data. Python, R, Java, C, maybe Swift. Swift should come here, right? And in memory, once you declare that in your memory, there's a language. When you say language, then language can be evaluated in this way by accessing that containment. And the first element in that container points to the first element by index 0, by index 1, the second element, by index 2, third element, by index 3, fourth element. So we can increase more and more. We can add on top of something already existed more and more. So it dynamically increases. Also can be decreases. If we want to pop this out, then that many decreased. Or we can remove or delete some. That will be possible too. Once you have this in your memory, then how can you access? As I said, because we have an index here, if we say language within that square bracket,
the index number 1, then that will point to the second element in this container, which is R. If you want to access the first element, then you need to put here 0. So lots of examples may be possible. This is, let me point out some. Yeah, you can start with empty elements in that list. If you want to add, then we have a language called dot append. This is like a function, right? My color, this is a variable, okay? List variable. This variable has some of the good features that we can attach to it with the dot notation. So my color dot append. Append is a function, so new element can be appended to this list, where it can be appended to the last ones. For example, here if I were to append Swift, then Swift comes next to the end of the current list. So that comes here, right? That's all append. Also, if you want to access, then you can do number 1. If we want to access the range, not only each individual, but if you want to access, here I want to access from the first element to the second element, then second element means the index 1, right? Then you should say 0:2. This is a beginning index. This is an ending index. But the value containment can be accessed from the beginning index to all the way to the ending index, but ending index itself is not included. Okay? So exclusive endings. Inclusive beginning, but exclusive endings. Then it starts from 0. Index increased by 1. So next one is 1. And 1 next to 1 is 2. But because ending index 2 itself is not included, then this will give you first element and second element only. Third element, not. So red and gold. 1 and 2, then if we say 1, this is not right? Returns, if red and gold here, then 0, 1, 2. Yeah, this is what it is. Accessed by range 1:3, then it returns red and gold. 1 means there's a second element, which is red. After that is number 2, still inside of this. So that is accessed. Number 3 is the fourth element, 0, 1, 2. Fourth element is not there, right? The language that we have here. Another way that you can access by negative values. If you have a long list in that container list, then each element can be accessed by index number. If it is very long, then it's not tedious to count from 0 to whatever, right? It is tedious, but it is time killing, right? This is index 0, 1, 2, 3. You have to count. So one thing that we can make it easier is that we can count from the last. So we put negative number. So negative 1 is the last element. If we count from the beginning, then we count from 0, right? If we count from back end, because there is no negative 0. Yeah, for mathematicians, negative 0 is meaningful, but in this index mechanisms, negative 0 is not available. So 0 there. And therefore they think, oh, okay, then the end element is indexed by negative 1. We can count it from, you need to say always from a smaller value to bigger value with the colon inside. So this is the last ones, right? This is, yeah, from negative 1, negative, that way. You can see the more methods associated or defined with the list can be found from help. Okay, if you say help and type list, then you can see those. I want to bring my Paizo so that we can see it. Okay, here is the Paizo. If I do help, then it comes to me the help page, right? On this prompt statement help, then you can say list. Then you may be able to see the method or function. Sort, that is a function. Reverse, remove, pop, insert, index, extend, and append. Append, then you see the method or function items here. Then we have a function name followed by open parenthesis followed by self. They're all self there. Followed by real parameter object. So append takes object as a parameter and do append. So the explanation of this append, if you see that, then append object to the end of the list. That's what it is. There's nothing about self. Self, you may be able to see what the self means when it comes to object-oriented programming, which will be the last topic of these Python modules. When you define a method in object orientation, the object orientation can, the primitive items in object orientation is an object. It starts from object. When you want to append, then what is a self? Then whatever that we have listed before dot notation, for example, my list dot append, then my list, that is a self. So I want to append object to myself. I want to clear myself. I want to copy myself. I want to count the value from myself. That's what it is. So for now, don't worry about the self. When you look up the dictionaries, help, then if there is a function, then always self. Okay? So when you code in Python for object orientation, as you create a class, then you should say self. So don't worry about it. There's too much right now, but this is what it is right now. All right. So there's help. Remove, insert, that's all possible. So we can practice lang, for example, len, the list. If we say here, len, len is it's not necessarily associated with the list itself, but append and count, these are associated with the list. Therefore, we say list, this is a self, dot append. Dot append, then what the literal stated before that dot notation, this is this is an object, and this is a method. This method is defined in this object. Therefore, we say object dot and method notations. Len, this is a primitive function, not like the function here append. Append is a function defined for the list, but len and max, those are the primitive function. Doesn't matter what object, but we can take it. So len takes that object itself. Max takes that object itself. The others, object dot function or method. Object dot functions. Append and extend. If you want to append an object college, then you can whatever the list, LST points, then college can be attached to the end of that list. We need to extend with literal. If you see here, yeah, extend is a method to itself. You can extend the literals. Extending list of appending elements from iterable. So you can append to the element. Those are literal. Literable means can be repeated. So list is a repeated, one element after another, after another, after another, like repetitive data types, right? That is a literable, which is not the case of object itself. Like college, then there's primitive data, right? College. But this is another list. So we can extend another list to the list. So we'll find out what is append and what is extend, the difference between these two. Count, that is defined solely for this list. Therefore, we have object.counts, 33. How many elements in that list? 33. So count what? Count these specific elements. If we want to delete the first if you want to delete the third element in the list, then you need to say del lst, and then this is the third one, right? Index 2. If you want to remove any specific value, then you can say lst remove 33. 33 is an element. We can have more: insert, reverse, sort, pop. So how to represent a number of objects? If we have a set of objects, then we may use a list. How can we represent an object itself? In other words, to describe this object, what kinds of descriptors that you want. Therefore, we have a set of descriptors that can represent that object. What I am trying to say here, we learned the list. And also we have a tuple. They are similar, right? So many other languages provides only list, like array. They don't really differentiate list from tuples. But in object, we do here. List is a container containing several values in the same type, same kind, several same kinds data, like John, Adam, Brown. They are same kind, right? On the other hand, tuple, it wants to describe an object, one object. In order to an object, what descriptors that we want to use. So for these specific ones, we can say what is the ID, what is the positions, what is the disciplines, what is the course, that type of things. So 1, 2, 3 is ID, positions, professor, course, discipline, cyber, course, IASP 505, something like that, right? Not many textbooks explain in this way, although that should be, right? Very nice, right? Okay, so tuple can be in this syntax, parenthesis. If we say Python, then untyped, £, indentation, self. If it is a Java, then Java is a typed language. If you want to put the comment, then Python use £, Java use //. What that means is that if anything beginning with the $, then your Python does not care. It is a comment. It is your comment. In other words, it is not evaluated. Same thing in Java, //, double slash, then don't count, right? Swift, also //. Many other languages use slash, double slash as a comment. But pound sign in Python and also in Linux operating systems. If you have code block in Python, then indentation is very important. The position of each line is started from the left, the position 0, right? That is outer code block. One code block may contain another sub code block. If that is a sub code block, then entire that code block, sub code block, needs to be indented within that outer code block. Therefore, by looking at that indentation, we may see, this guy can be contained in this container, which is also contained in outer container. So it is a multiple depth of the indentations possible. Java, on the other hand, simply we say curly braces, open curly braces. All the codes until we meet end curly braces, they're all sub code block. So more explicit indicator for the block for Java or Swift or C. But Python, indentation is important. About object, how we can indicate an object. Python, we call it self. Java, this and self, right? Only the language difference. The example that I put here comes from my textbook, but it is not required. Let's say if we have list, and I call here Python in that tuple, right? Tuple formats. It should be tuple format, right? Parentheses rather than square bracket. If it is a square bracket, then accurately speaking, all the elements in that square bracket should be the same type, same kind. But untyped and pound sign are not same kind. Pound sign and indentation are not same kind, right? They are all together constitute Python. Look here, they all together constitute Java. It's different languages, right? This, because this is a descriptor, if we drop any of this, then it may not be Python, right? What I'm saying here is that tuple as is, any element here cannot be modified. If it is a list, yes, we can. We can modify, we can drop any element, we can add more. But as far as tuple, literally, tuple is a sequence of a series of descriptors. So if you change the descriptors, then it doesn't point to that specific object anymore, right? Semantically, therefore, not allowed, which is good in cybersecurity. It's too early to say that, but yeah. But because of a tuple, sometimes you can manipulate the data in a secure way. If you want to share the data with others in tuple format, then the other guy cannot modify it, right? That type of things. But there is a way that you can modify it. In other words, this tuple itself can be converted to a list. If you want to convert this tuple to a list, then you need to say list and tuple variables. Then it can be changed to a list. Once it is in a list, then you can use the method that is available from that list. So dot append possible. Once you change anything of this, then you can convert it back to the original tuple formats. In order to do that, you need to do tuple, right? Tuple, list, those are We don't call it function in object orientation. We call it constructor. Okay, looks similar because, like a function name, open and close parenthesis. This takes a parameter. Looks similar, but we call this a constructor. So Python tuple can be constructed in a list. This is a list, PYLST, because it is the outcome of this conversion. So this is a list. List can be converted back to tuple by calling tuple. We will practice that. So tuple does not have many methods. As I said, it's a series of descriptors. Main idea is not to modify it, right? We want to keep it. How can we maintain it as is? So not many methods developed. But there is a way that you can do if you have to do. You need to first change it to a list, and then you can play with all the features available in the list. And at the end, you have to convert it back to tuple. Then you will be okay, right? So only two methods, tuple, count, and index. So if you come here, this is the list. But if you say tuple, tuple math, see here, tuple, we have count and index. Only two, right? Count, text value, so returns the number of occurrences of that value. Fine. Index returns first index of the value. If you want to say, I want to see the index of this specific value, then you can say index John. Then in that tuple list, it may tell you the position of that element John. Dictionary. Dictionary has also the method called update. So we can use this method update to update the dictionary. Dictionary should be updated, right? What that means is that we can add more items, more key and value pair, or we can update the definition of the given key. Because dictionary is a key and value pairs, if you want to get, there's a method. These are the good methods, so that we can take a look at that. Dict, then there's an update. Set default, pop item, pop keys, get, first of all get, then return the value for a key. If key is in the dictionary. Otherwise, if there is a default, then default can be given to you. Items, set of, like object, set of all the items can be returns. If you say keys, then set of keys. Set of keys. Set of all items, then items. Set of all keys, then keys. Values, then set of all the values. Somewhere here. Values, no values. Set of all the values. You can see this, right? Items, keys, and values. And so we looked at three major types, data types available in Python. Python has many more data types available. Those are not primitive, but anyway, they are so great and very, very useful in many cases. But we don't touch it from this basic level of codings. Among those three, basic data types. There can be, so data type is like a container, right? So that container may contain another data types, which can in turn contain another data types. This is more like deeper levels and nested type of data constructed. If you see here, from here, there's a square bracket to the end. There's an ending square bracket. Entire is called a list. But if you see the elements, then this element itself is a tuple, right? Because first element is a tuple of two tuple elements, 131 and Python. If we say, I want a list of key and value pairs. No, I want a list of each course in a tuple. So course ID, CRN number, and course title in a tuple. 131 Python, 231 Java, 335 pen testing, 555 mobile tech, 585 as advanced crypto, 570 mobile cryptos, for example. So this is called a list of tuples. The list can contain, list is a container which includes tuples. That's what it is. You can think a list of dictionaries, or you can say list of a dictionary of tuple, dictionary of list. You have so many different combinations possible. Okay, so this is a list of dictionary. Then each element is in the form of dictionaries. Therefore, it has key and value pairs. Capital Washington, strength finance. Capital Tokyo, strength science. Capital Berlin, strength engineering, for example, right? So we can say this is a list of dictionaries, as I said here. Each dictionary contains key and value pairs, but there are two keys, capital and strength. Similarly, we may think of a list of tuples that we looked at earlier, right? Or dictionary of key and value pair, but value itself is a list. We call it dictionary. Dictionary is a dictionary variable. This dictionary variable has key and value pairs. Mercy, there is a key. If you ask about Mercy, then I can give you the value associated with that key. The value here is a campus location, right? DF, MT, BX. NYU, then NYU, the key, then I can give you the location of the campus. NYC, Dubai, Shanghai. If you give me MIT as a key, then I can give you the location, Cambridge. All right, so this is the concept that we look at, and collab. Collab that I think I posted, right? So you can, this is IPYNB files. You can click to download your local drive, and then you can bring it back to your web browser and open up collab.research.google.com and upload it. So please do it now so that we can go together. That is lab 2. So data types. I explained all, not all, but somewhere here, somewhere in the slides, sometimes in this lab. I wanted to read that. It's an example of a list. This is a list, right? Student is John, Adam, Chris, Brown. You can add more and more, right? You can add here, say, Bob. Manually. But you can use a method to add one more element, Peter, and print it so that you can see whether that is printed. So right now I want to and click to run. So if you want to see the list itself, then you need to put here student, right? That way you can see the list of students. John, Adam, Chris, Brown, Bob, that is given. And you want to append Peter. So Peter is appended. So up to this, that is counted. Next one, access an element of a list. Third element. So how can you do the third element? That's a student. And third element, therefore, that is index 2, right? Index starts from 2. So if you want to see it, then Chris. First, second, and third, Chris can come in. Second last element. Second last. Then you can count it from the beginning all the way to the last, second last. But if you want to see it, if you want to count from the last back end, then -2, which is the second last. So you can see that second last is Bob. If you want to keep this print, then you need to keep the print there so that it'll come always. So Chris first, and then this is the last ones. So without having to call that print function, you can print it as you can see there. But now I want to put the print. Access multiple elements. So if you want to do, I want to see, for example, which ones can be printed. Angelica. If I say 2:4 from students, this is the students, right? 2:4. 2 is the third element, right? 0, 1, 2. So Chris comes.
It will be from Chris to Bob.
Chris to Bob. This is the 2, 3. This is 4, number 4. Did I say 4 is included or excluded? In this range notation, beginning index, colon, ending index, then ending is, it counts all the way to the ending itself, ending index, but which is excluded. What that means is that then this is a second, this is number 2, this is number 3, next one is number 4, but number 4 is excluded. Therefore, we should have a Chris and Brown. Let's see what happens. Run it. It's a longer time. You guys might have quicker response. But here at Mercy University, from my office, takes forever. There is a warning. Saving failed since 12:23, 1 minute ago. Click. One more. Automatic saving failed. This file was updated remotely or in another tab. Okay. All right. So when I do this, it gives me a sublist. Adding a list to the list using extend. So if we do extend, I want to comment this out. And rather than this underline, if I say extend and run it, then it gives me, although I put there a list, it can be extended within that given list. Okay? But in other words, if I want to say print student append, and I say C D, if I want to append that, automatic saving fails. Probably does it run slowly at your side as well? Or only it happens to me? Anthony, is it slow at your side?
No, it's fine for me.
Like here, okay. All right. So I have I did append. Why it doesn't? Okay. And then if I do okay. So this is C and D. Very similar to A and B here, right? Only difference here, extend and append. If we do extend, then each element can be appended. That is what extend, the definition of extend. Extend. Extend, list by appending element. Appending by appending element. By appending this element. So element can be appended, like append here, append Peter. This is an object that is appended, right? So if you do extend, then it should be written in a repeatable. So each element can be appended. Okay, append, then this entire can be treated as an object. So entire can be appended like this. What if we do append, for example, extend? Look here. So it says this itself is a repeatable. String is repeatable. String is a repeatable of what? Each character, right? So element in this repeatable is a character. So M can be appended, E appended, R appended, C appended, Y appended. Okay. If you do this append, then if you do append, then the parameter itself is an object. That object can be appended. Extend, then the parameter is treated as iterable. So you can think, oh, what is an element in that string? Element in a string is a character. So each character can be appended. Next one is how many elements in the student list? Then here, by the way, your midterm exam is coming soon, right? I would say I will post it, but today is the last Tuesday of February. I would say 2 weeks from today. Or third week, which is the second week of March or third week of March. Third Tuesday or second Tuesday of March, 12th or 19th. I will decide that because we have a very small group. I do not want you to come, but one requirement, I want to continue to turn on your camera so that I can see you guys. So I'll be the proctor. I want to check your the midterm exams. So I'll be with you, but remotely, virtually, so we all can see the camera. What I'm trying to say here, the types of questions is like this. How many elements in the student list? Fill in the blanks. Then there's underlying blanks, but you need to say len students so that you can see the number of elements. How many elements? 1, 2, 3, 4, 5, 6, 7, 8. This whole thing is an object. 9, 10, 11, 12, 13, 14, 15. So 15 elements, right? One more thing that I want to do here. If we want to see, for example, from -4 to -2, from here, -4, and -2 is the second last, right? So second last. So far student is, yeah, this is the students. This is -1, -2. Bob, Chris and Brown. -4 to -2. Oh, because -1. See what happens. Okay. Students. Student is appended to Peter. So student always to Peter. So -1 should be strange. So student -1. So what it is? Oh, right now we have here. Okay, so -2. Because of this. -2 is y. So for example, -4, -1, -2, -3, -4. So negative cases, if there's a positive, then this is the beginning and this is ending. Ending is exclusive. But if it's a negative, then it counts all. Because it doesn't count from, somehow it works that way. No. Same thing. Yeah, same thing. Negative is not counted, right? Negative itself is not counted. We count -1, -2, -3, -4. So from here, -4, add one more, then -2, add one more, -1, -2, -3, -4. So -4, that is all. One more, then -3, one more, -2, but ending exclusive, right? So we have only, yeah. If it's a negative, then always confused. But anyway, that is. And we have, yeah, we looked at that. Okay. So homework there. So here, the way that you need to submit the homeworks. Some of you may be confused. Here's what I want. Let's say this is the code that you. Let's say this is your code, okay? The way that I ask you to do. So you highlight all this, and then you can copy it. And at the very beginning, you need to say, this is a homework problem 1.2, for example, okay? And this entire thing should be evaluated. Oops, I need to quit. Evaluated like this. Okay, so make sure that it is evaluated. Oh, it's not here. It should be somewhere here. And so you save this in your somewhere, for example, 505 class spring 24, and you can say homework 2 that is, the format of that is py. So dot py, and come back your then there is a homework 2, right? So this homework 2 is very similar to, yeah, that is a homework 2. So plain text files, code itself. This should be, so this entire, that should be included in your submissions, okay? File itself needs to be submitted. That is the way that you can do homeworks. Tuple, this is tuple, very similar to the list. We can access the third one by index 2. Try other methods. So if you want to do append and extend, it's not going to work, right? Student Adam append nationality USA. I want to put another descriptor, but it's not, right? It says tuple object has no attribute append. Of course it is not. That's what I wanted to do here. How can you modify it? Then you need to change it to the list. Any possible way that you can do? You can do first Adam list equals list Adam, and then if you do print student Adam list, then you can see this is not anymore tuple but a list, so that you can use any methods available in the list that we looked at here, right? Any one of these can be possible. There's a tuple. Dictionary in the curly braces. So that is the dictionary. If you want to access an element, then remember that list and tuple position is important. Therefore, you can access an element by index. But dictionary, position is not important. Key is important. Give me a key, I can give to you annotation, definitions. So key should be given. For example, what is the major? Then it gives me, because a major is a cybersecurity, it returns a cybersecurity. List one of the keys in the dictionaries. Oh, a list of the keys. How can we get the list of the keys? Then you need to do here. Student is a dictionary. That is a keys. Keys is a method. It gives us this. It says a dictionary keys: name, age, major, educations. If you want to give literally list itself, then you need to do list student. I'm sorry, it's not there. Put that here. Dot keys. Then it gives us, if you say student keys itself, then it gives me this. Literally, if you want to see list only, in other words, this only internal this, then you need to say list. This is a constructor of the list. So it gives me this. List of the values. Then you need to say here, student and values. Open and close parentheses. So that is a method, that is a function. Therefore, you can see here, value only. John, 29, cybersecurity, Mercy universities, right? Value only. Pretty list of the values. What do you mean by that? The literally values, values themselves in a list. Then you need to do list. Oh, print. Then you can see the values only in a list. Update. There are two ways that you can update. Number one is to use update the function or using a key. So if you want to do updates by adding, for example, major age. So I want to update the age. Currently 29, but 30 turns 30, so that we can see. So 30 here, right? It is updated. The update, the primary itself is a dictionary format. It's not like update to 30. We do not know what 30 is, right? It should say 30 for the key age. So they should be in this form. We can do that using key value, the key itself. So if we want to do, for example, John age major education. I want to change the education. Change education to, say, MIT. Then it can be changed to MIT. Okay. Similarly here, if we want to do, oops, where is it? Oh. Okay, here, Pythons. I want to update the key skill with the value Pythons. What would happen in this case? We know that if it is age, then age can be updated to 30. There's a key not available. There's no skill. If it is the case, for a moment, if we do that, then if there is a key, then we can update the value. If there is no keys available, then add that. So skill is added. Okay. Similarly, therefore, so MIT is there, right? Now, if we do hobby, hiking, then it can be added because hobby is not the key available there. Therefore, hobby is newly added and value as well with it. Extension. As I said, these three basic data types can be, one can contain another, which can contain another and another. So depth of that data types be great, deeper levels, right? A few of those examples is department of dictionary in a list of department information. So this is a list. Out container is a list. Each element is a dictionary. Name Cyber, chair Chris. Name CS, chair David. Dictionary values can be a list. So in this dictionary, see here there's curly braces. Value for Adam is a 99, 78, 87. Bob, the value is a list. So it could be a transcript. Another could be a dictionary contains another dictionary. So dictionary values will be another dictionary. Adam is a key. Value for Adam is a dictionary. So Adam's homework is this. Adam's exam, this. This whole thing is about Adam's. Bob's homework, this. Bob's exam, the other. And so on and so forth, right? let's say we have students, many students in dictionary formats. We can collect all of those dictionaries in a list. Then you need to say, in a list, student 1, student 2, student 3. Then this student JSON is a list. Each element is a dictionary, as you can see here. So there is a homework assignment also. Okay. How can you access, for example, here, not this, JSON here. How can you access first dictionary? Then you need to say here, first dictionary is, because JSON, this student JSON is a list. First element is a dictionary. First element in a list can be accessed by an index 0. So you can have, that's the first element, right? If we want to see what is his age, what is the first student, what is the age of the first students, then you need to do here JSON, student JSON, first element, and then you can say what is it, age, then 29. So that age can be accessed. So each one of these can be accessed anyway, right? Although that is a very, very complicated formats like this. Very, very complicated formats. You can pinpoint any specific value to obtain. So lots of things, right? So I give you quick lecture and lab. So practice this and watch and follow step by step using your Colab notebook. When you complete your homework assignments, then you can take that code itself in a file, so that the way that I can evaluate is to execute your files to see it gives me the result, okay? That's what I want to say. Any questions?